The universe is filled with billions of stars. But when we look at the night sky, they all look the same, just tiny points of light. In reality, stars are not the same. They are born differently, live differently, and die in completely different ways. Some live for trillions of years, some explode in seconds, and some collapse into black holes. Today, we will explore all major types of stars, from birth to death. Protostars. A protostar begins its life inside a giant cloud of gas and dust called a nebula. Gravity pulls this material together slowly over time. As it compresses, the center becomes hotter and denser. This stage is called a protostar. The protostellar phase lasts roughly 100,000 to 500,000 years. Over time, the internal temperature and pressure of the core become immense. Once the core reaches about 10 million degrees Celsius, nuclear fusion ignites, fusing hydrogen into helium. Once this stable energy production balances the crushing pull of gravity, the protostar transitions into a fully fledged adult star on the main sequence, ready for the next type of star. The next type of star is red dwarf. They are officially known as M-type stars. Red dwarfs are the smallest, coolest, and most common type of stars in the universe, making up about 70% to 75% of all stars in the Milky Way. They range from just 0.08 to 0.5 times the mass of our Sun. They are the coolest main sequence stars, with surface temperatures between 2000 and 3500 Kelvin. Red dwarfs' flares are massive, explosive outbursts of energy caused by tangled magnetic fields. Flares of red dwarfs can be hundreds or thousands of times more energetic than the largest solar flares produced by our Sun. Even though they are faint, they are extremely long-lasting and stable. I think you all would not believe this type of star, but it is. Orange dwarfs. They are officially known as K-type main sequence, and also they are the cosmic sweet spots. They are slightly larger than red dwarfs. They are stable stars that can support long-lasting planetary systems. Slightly smaller and cooler than our Sun, they possess 0.5 to 0.8 times the Sun's mass and live for 20 to 70 billion years. They are larger than red dwarfs, but smaller than yellow dwarfs. Their surface temperatures range from 3,900 to 5,200 Kelvin. Our Sun will render Earth uninhabitable in roughly 1 billion years. But orange dwarfs remain stable and active for tens of billions of years, offering abundant time for complex life to evolve. Here comes the golden dwarf, yellow dwarf. A yellow dwarf, G-type main sequence star, is a medium-sized star that fuses hydrogen into helium in its core. They typically range from 0.84 to 1.15 times the mass of our Sun. Our Sun is also classified as a G-type main sequence star, G2V, which is commonly referred to as a yellow dwarf. Despite the name, these stars actually shine in bright white light. The Sun only appears yellow to us because Earth's atmosphere scatters the shorter, bluer wavelengths of light, a phenomenon known as Rayleigh scattering. Surface temperatures range between 5,300 and 6,000 Kelvin. Here comes my favorite one, blue giant stars. Blue giants are massive, exceptionally hot stars that shine with a brilliant blue-white light. Surface temperatures range from 20,000 to 50,000 Kelvin compared to the Sun's 5,778 Kelvin. They are incredibly bright, often shining 10,000 to millions of times brighter than the Sun. They have a radius about 5 to 25 times larger than the Sun. While a yellow star like our Sun will live for about 10 billion years, a blue giant burns through its fuel in just 10 to 100 million years. When their core fuel is depleted, these stars expand into red supergiants before violently exploding as supernovae. Red giants are among the largest and most massive stars in the universe. They typically begin as massive stars 0.5 to 8 solar masses. Their surface temperatures are relatively cool, ranging between 3,500 to 4,500 Kelvin. Because they are so massive, they burn through their nuclear fuel incredibly fast, White dwarf. White dwarf is the incredibly dense, Earth-sized remnant of a low to medium mass star like our Sun that has exhausted its nuclear fuel. It is officially classified as stellar remnant. A single teaspoon of white dwarf material would weigh around 15 tons on Earth, which shows it has extreme density. Most observed white dwarfs are highly concentrated between 0.5 and 0.7 solar masses. White dwarfs fall into an intermediate bracket between 8,000 Kelvin and 40,000 Kelvin. A strange phenomenon occurs in white dwarfs, which is electron degeneracy pressure. It is a bizarre quantum mechanical force that stops a white dwarf from collapsing into a black hole, which also prevents it collapsing into a supernovae. Black dwarf. A black dwarf is a theoretical concept. It is a white dwarf that has completely cooled and no longer emits light. The universe is not old enough for any to exist yet. I think everyone knows this neutron star. A neutron star is the collapsed core of a massive supergiant star. A single sugar cube of neutron star material would weigh about 1 billion tons, the weight of a mountain on Earth. Only about 10 to 15 kilometers in diameter, roughly the size of a city. 1.4 to 2.5 times the mass of our Sun. When a star with more than 8 times the mass of our Sun exhausts its nuclear fuel, its core violently collapses. The gravity is so extreme that it crushes electrons and protons together to form neutrons. This creates a massive outward neutron degeneracy pressure that stops further collapse, leaving behind a dense, hot neutron star. Here comes the spinner. The pulsar. A pulsar is a highly magnetized, rapidly spinning neutron star that emits beams of electromagnetic radiation from its magnetic poles. Though only about 20 kilometers across, it packs more mass than our Sun. It spins 716 times per second. A pulsar's average surface temperature drops drastically as it ages, ranging from 1 million Kelvin down to less than 42,000 Kelvin. They start incredibly hot, but gradually cool down over millions of years. So thank you for watching my video. Stay tuned, share and subscribe.